Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. Now, if my videos are very helpful in your studies, also don't forget to subscribe. So, by the method of least work, compute the horizontal and vertical displacements at E as well as the member forces. Cross-sectional area for the vertical member is 150 mm square and 200 mm square for the others. E is 200 gigapascals. So here is the figure. Then this is truss with which is indeterminate to the second degree. Therefore, we select two redundant forces here, and I select AE and BE as our redundant forces. The slope of AE is 345 because this is 1.2 plus zero point 0.8, so 2 meters vertically, 1.5 meters horizontally. So 1.5 divided by zero point 0.5 is 3. 2 meters divided by zero point 0.5 is 4, so 345. Then we have for CE, which is 1 and 1.2. The slope would be 5 horizontal, 6 vertical, then square root 61. Common is zero point 0.2. Then this one is 3 horizontal, 2 vertical, so 3, 2, and square root of 13. We will call AE as F and BE, the other redundant force, as Q. And then CE, let's just call that S sub C, and DE, call that S sub D. Then P1 would be the horizontal load. So we'll eliminate that and this one. So this is P1, which is 103.92. 120 times cosine of 30 is 103.92 in decimal, while the net vertical load at E is 120 sine 30, which is 60 downward plus 80 downward. So the net vertical load would be 140 kilonewtons downward, and we will call that P sub 2. So S sub C, summation forces X. So S sub C times 5 over square root of 61 plus SD times 3 over square root of 13 plus P1 equals F times 3 over 5. So expressing SC in terms of F, SD, and P1, so it is equal to 0.93723 F minus 1.2997 SD, then minus 1.562 P1. Then summation forces Y, SC 6 square root of 61 plus SD times 6 times 2 over square root of 13 plus F times 4 over 5 plus Q equals P sub 2. So expressing, substitute SC from here to derive SD. So quantity times 6 over square root of 61 plus SD times 2 over square root of 13 plus F times 4 over 5 plus Q equals P2. So combining for SD and simplifying, we have 1.52 F minus 0.4436 SD minus 1.2 P1 plus Q equals P2. So S sub D equals 3.4253 F plus 2.2535 Q minus 2.7042 P1 minus 2.2535 P2. So we have expressed SD in terms of the redundant forces and the other loads P1 and P2. Then we'll also express SC in terms of F and Q and the other forces. So from here, SC 0.93723 F minus 1.2997 SD, and SD is given by this, so substitute minus 1.562 P1. So simplifying, S sub C, combining like terms, negative 3.5146F minus 2.9289Q plus 1.9526P1 plus 2.9289P2. Let's then tabulate. So this will be the tabulation. So the members involved are 4. So SAE is F and F. SAE is F, and the partial derivative of S with respect to F is 1. The rest 0, 0 with respect to P1, with respect to P2, 0. The length is square root of 1.5 square plus 2 square, so 2.5. Then this is F times 1 times 2.5, 2.5F. Then 0 here, 0, 0. Then BE is Q. So partial derivative of S with respect to Q, 0. Here is 1, 0, 0. The length of Q is 1.2. Then 0. Q times 1 times 1.2, 1.2Q. 0 here, 0. Then CE is S sub C, negative 3.5146F minus 2.9289Q plus 1.9526P1 plus 2.9289P2. So partial derivative with respect to F is negative 3.5146. With respect to Q, negative 2.9289. With respect to P1, 1.9526. With respect to P2, 2.9289. And the length of CE is square root of 1 square plus 1.2 square, and that is 1.5620. So in your calculator, to evaluate these values here, first entry, negative 3.5146 times negative 3.5146 times 1.562. Then put the value here, 19.294F plus 16.079Q minus 10.719P1 minus 16.079B2. So for the first, negative 3.5146 times negative 3.5146 times 1.5625. For the second here, replace this, only replace this by negative 2.9289 to get that. For this third, replace negative 3.1446 by 1.9526 to get that. For the fourth, replace negative 3.5146 by 2.9289. So the rest, negative 3.5146 and 1.562, remain the same. Then same is true here. This value times this for value at a time, 1 at a time, times negative 2.9289 times 1.562. So only these two will not change. Then for the first factor, replace it. First this one, then next this one, third and fourth, then you'll get 16.079F plus 13.40Q minus 8.933P1 minus 13.4P2. Then do the same. Negative 10.719F minus 8.933Q plus 5.9554P1 plus 8.933P2. And for the last, negative 16.079F minus 13.4Q plus 8.933P1 plus 13.40P2. DE is SD, so let's transfer it here. Earlier SC is this one, so transferred here. So the SD is this value. Then the partial derivative of S with respect to F is 3.4253, 2.2535, negative 2.7042, negative 2.2535. The length is square root of 3 square plus 2 square. Square root of 13. Then evaluate here. These are the values. This quantity times first 3.4253 and square root of 13. Then this value times same, this 2, and so on and so forth. Then with respect to QL, that's the value. Then S partial of S with respect to P1 times L, this will be the results. Then finally for S partial of S with respect to P2 times length, that would be the value. Then apply summation of S partial of S with respect to F times length over AE equals 0. So adding this, remember that only BE has different area, but because it is 0, so we can combine like terms here. For this, then divide by AE equals 0. So summation of S partial of S with respect to F length over AE equals 0 equals, so 2.5, we can combine it with 19.294 and 42.303. Then for the Q combined for the P1 and for P2. So if we simplify, this will be the result: 64.097 F plus 43.91 Q minus 44.116 times P1. The value of P1 is 103.92, and minus 43.91 P2 equals 0. So simplifying, 64.097 F plus 43.91 Q equals 10731.93. Call that equation 1. Then summation of S partial of F with respect to Q length over AE equals 0 also. So take note that this BE here has different area. So let's separate it first before, and these two are combined because they have the same area. So 43.91 F plus 31.71 Q for this, then minus 30.905 P1 minus 31.71 P2, negative 13.4 and negative 18.31 P2 is negative 31.71 P2 over area, which is 200 for the other members, E. Then this is for this 1.2 Q here, the area is 150, vertical member, E equals 0. So simplifying and combining, we can now combine Q because of different denominators. So 0.21955 F, that's 42.91 over 200, and plus 0.16655 Q, that's 31.71 over 200 plus 1.2 over 150. And for the constants combined equals 38.255, equation 2. Solving these two equations simultaneously, then F, which is equal to SAE, equals 103.995 kilonewtons. Q, which is equal to SBE, equals 92.602 kilonewtons. So for the horizontal and vertical displacements, so this is for the horizontal displacement, delta E horizontal. So delta E horizontal is summation of S partial of S with respect to P1 length over AE. So we can combine because BE is 0 and AE is 0, so these entries here have the same area. So combining, negative 44.116 times F, and F has been found. So that's negative 10.719 and negative 33.397. So negative 44.116 F minus 30.905 Q, negative 8.933 and negative 21.972 of Q, plus 32.3214 of P1, this is P1, plus 38.93 and 21.972, 30.905 of B2. Then because this is kilonewton meter, we multiply 1000 squared to make it Newton mm. This is mm square and 200,000 Newton per mm square. So therefore this is newtons in the denominator. So that gives us an answer of mm, unit of mm. So delta EH is equal to 5.896 mm, and that's rightward. For the vertical displacement, let's have it adding this one, and because we ran out of space, let's put it on the next slide. So let's have the clip of the tabulation earlier, and the values of S sub D and S sub C, or SD and SCE. Then for the vertical displacement, we can add this directly because they have the same area. So delta E is negative 60 summation of S partial of S with respect to P2 length over AE. So negative 16.079 and negative 27.831, that's negative 43.91 of F, and this is F. Then combine the Q's, this is Q. Then combine the P1 8.93 and 21.972 is 30.905 of P1. Then 13.4 and 18.31 is 31.71 of P2 times 1000 square over area 200 E 200,000. So delta E vertical, if this is positive, so it is downward because P2 is downward. So it agrees with the direction of P2. So 3.705 mm downward. But okay. Then for SDE, SD or SDE is 3.4253 of F plus 2.2535 of Q, that's Q, minus 2.7041 of P1 minus 2.2535 of P2. So the stress in member DE is equal to negative 31.618 kilonewtons. Then for S sub C, substitute here, negative 3.5146 of 103.995 minus 2.9289 of 92.602 plus 1.9526 of 103.92 plus 2.9289 of 140. So S sub C or S sub CE is equal to negative 23.6763 kilonewtons. So these two members are in compression